Hello and welcome. Today, doing something a little different. We are just going to sort of just discuss some of the things that I've been working on outside of what's typical. So first I wanted to discuss like compute shaders and Bevy and just give a rundown on sort of my take on them inside of Bevy. Let's go to the Bevy repo to do that because I've got a draft PR open for this. Yeah. So essentially, what sort of has changed is pipeline descriptor is now specifically like a render pipeline descriptor or a compute pipeline descriptor. Where's the compute pipeline descriptor? So here, it's pretty much the same exact thing, except compute pipeline descriptors don't have information about vertex buffers or they don't have vertex descriptors, right? There's nothing to describe how vertices work or anything like that, or how the fragment stuff should work at all. Um, so it is compute shaders are very different in that regard. You still have your typical layout though, which includes all your bindings. And I kept some of the shader stages, and I even kept the specialized pipelines as well. Because I think that's helpful for doing shader defines and stuff, which I think we should allow still. So I kept most of that stuff in place. And then internally, Bevy has something called a pipeline compiler. Um, which compiles pipelines. Like it compiles really, I don't know if that's the best way to describe it. It creates pipelines based off of those shader defines. This is definitely more in depth into Bevy than maybe what people are normally used to seeing on this stream. So I'm not going to go into great detail, but essentially it's pretty straightforward on um, how pipelines get created. Not much of that has changed. The only thing is we added support for compute pipelines. So you would create a compute pipeline in a very similar way to how you create a regular pipeline. I can show that off here in the examples. That one's but not a good example. Shader define is probably a better example. Let's see here. Yeah, so essentially virtually identical to something like this. And compute has the shader stages compute. It doesn't have vertex or fragment. That's important to realize. Um, but it's still, actually, I might have to change that. That might be one thing that I overlooked with the shaders. Oh no, I did keep them separate. Right. So there's a compute shader stage, which has a compute shader. And that's how you should do it. Compute shaders are always going to run on their own. They never run in a group with other things. Where like vertex, for example, can run with a fragment shader, but it doesn't have to. You can just run a vertex shader by itself. So that is an option. You can also have multiple fragment shaders to one vertex shader, right? So you can have multiple fragment passes, but only one vertex shader. So there's different things that you can do like that. Although Bevy doesn't really allow you to do that. But yeah, so all we really do is expose sort of the basic compute structure to people, which looks like this. The ability to get the render context for the pass, for Bevy really, the ability to set a specific compute pipeline, and then the ability to dispatch work and to set bind groups. So dispatch, what this does, and we really need more documentation here, but these are the work group threads, I believe that's what they're called. And WGPU has more docs on that. So if you look up dispatch, yeah. So X, Y, and Z denote the number of work groups to dispatch in each dimension. So yeah, pretty straightforward there. If you don't know how compute works, I strongly suggest you look at a tutorial first before trying to use this stuff. But yeah, and then expose the set bind group. So there's no like automatic binding like you have with render resources and the main pass. And right now, currently, I think that's how it should be. I think this should get merged in first. And then what this sort of opens up the door to is I have a better idea for how people should use compute inside of like this entity component framework, entity component system framework that Bevy has, right? So inside of Bevy ECS, I have this great idea about how compute can work very well inside of that arena. And so you can then create your code and open up a PR for Bevy and say, here, take a look at this, see what see what you think. You can also even do like an RFC or whatever they're called. So I think, but this gets you the door where you could actually like experiment and work with compute, right? So where before you didn't have pipelines for compute, you didn't have the ability to have compute passes at all. So this does a lot in terms of allowing you to do things. And you can see here the render context has a begin compute pass, which gives you that compute pass. And you can sort of see more in depth on how that works too if we find the implementation for that. So it's pretty simple. You pass in a function that gets a compute pass, and you sort of build your pass out here, and then it creates an encoder so that you have workload that you expect, all that kind of stuff. So one downside to this is that currently encoders aren't really multi-threaded, so that kind of isn't great. But we can change that eventually in Bevy and make it so that they run asynchronously more. There's no reason why we shouldn't be able to. But yeah, the create compute pass is pretty simple. It just gives you the GPU compute pass, which again is really simple. One thing I'd like to see improve in Bevy in the future for both render passes and really any resources that it uses is if we could pass labels like to the actual descriptors for those objects, right? So if you load a texture in and you have the file name, right? Because it's an asset, and you create a WGPU texture with that, you can use the label there to say, hey, this is the name of the object. And from there, if you're using something like RenderDoc or Xcode, right, you'll see those names in there. So it makes identifying textures and like render pipelines, pretty much everything a lot easier. Passes, everything. um, so when you're actually debugging stuff, it makes your life a lot easier. But anyway, so that's basically the gist of it. It's not very complicated here, and it's like virtually no higher level support, right? It's all very low level um, into Bevy. There's nothing that really makes it easy for users to use. But I do want to discuss how we can come up with an API that makes it easy to use. And I think there are two different areas that we have to concern ourselves with. The first one is I have a compute shader that I wrote. It calculates some sort of data that stays on the GPU, and then during the render phase, I expect that data to be there, to have already been calculated by compute, and I want to run it, right? That's a typical compute workflow. That's quite common. You can implement things like, what was I gonna say? Implement things like clustered shading, even more advanced effects like volumetric rendering, all that kind of stuff with compute. So compute is very powerful. And if you keep the data on the GPU, that's the simple approach, right? It's very easy to comprehend. But there are cases where you want to get the data back from the GPU and bring it into CPU memory. And in those cases, compute, we need a different API for handling that, right? We can't really use the same one because it's a different concept. So I've kind of thought of these two different ways that, and there might be more ways, right? I don't know, maybe. But the first one's real simple, right? You create a compute, sort of like main pass. You create a node, you create your passes in that node, and you stage it so that it happens before the render, the main pass node, right? That part's fairly simple. The second part is a little bit more complicated, but I do think I've thought of a way which we can do it inside of Bevy. So I'm sort of currently thinking of this idea where you have a asynchronous system around compute, because compute doesn't, like, you can dispatch some work and the GPU might take very little time if it's not very complex work, or it could take a lot of time. And you don't want to block your main render, right? So the thought I'm currently having is if you have a heavy compute workload, you're going to want like some async, basically code to run this. Because the GPU it's not going to be instant, and you can block on the GPU, and that might be a case where we do that. But I don't think that would be very smart because you're going to get hiccups and like sort of like pauses, like in your rendering, right? So you're not going to achieve 60 FPS or whatever your target frame rate is. You're going to have frame rate glitches, essentially, stutters. If you start like pausing until essentially blocking until the compute finishes. So the idea that I kind of thought of is this compute resource, right? That lives inside of Bevy, and it's all it really does is it says, okay, dispatch this work, and then I give you back a task. It'd be called like compute task or something. And really, it's just a struct that wraps around a regular Bevy task. I thought about using Bevy tasks, but I thought it might be good if we like differentiate between like actual compute tasks versus like Bevy tasks. So I think it just makes sense to wrap it and have it be its own thing. Uh, and so what happens is it awaits for the data on the GPU, however long that takes. So it could take like sort of be spread across multiple frames or something, right? but it's just going to wait for that data to finish. And then when it does, it can read the buffer back and spit out the data into your thing and then let the user know that, hey, it's complete. And so this resource would kind of be a higher level struct that sort of manages all of that. It creates the tasks for you. It has a task pool or whatever internally, or it uses the one that comes from Bevy internally. Whatever makes sense. I'm not sure exactly on that. I have to do some testing to figure that out. And then it gives you a way of figuring out if your data is ready or not using the task, the compute task, right? And an ease of use, right? I don't think people should have to write a no-op walker to sort of like pull the async task and figure out if it's done yet or not. I think we should sort of handle that from a higher level and be like, hey, is my work done? If it is, then great, cool, and I can move on. So that's kind of the idea there. And so you would have a system that takes this resource and you say, okay, dispatch this workload to the GPU. And then in that same system, or even in a different system, you would say, okay, well, give me the data back from that, or the data is updated, right? And we'd have to integrate render resources into that quite well in order for it to make sense, I think, from like a workflow perspective, where you have a render resource storage buffer, and essentially that is your way of like getting data to and from the GPU/CPU memory. But I think that should happen automatically. I think that makes sense. But yeah, that's kind of the two ideas I have so far. The first one's really simple. It works a lot in the same way a main pass works. And yeah, I think I can even show you how, like if we look at Bevy Sprite as an example here, where is it though? I think it's in the actual entity. You have the sprite bundle, so you have like this main pass here. This would be like your compute pass, and you'd tell Bevy, you would have something like this, and you'd tell Bevy that there's X amount of workloads, XYZ amount of work threads or whatever they're called. And then you'd have a render resource that goes along with that. So very basic, simple. And that's kind of what I implemented a long time ago. Back in August, I guess, of last year. I ended up closing that PR because there were some things that it was missing. Specifically how to get data back from the GPU. It never did that well. Oh, that's weird. Should be there. Pretty sure it was yeah, there we go. Do have to search for it. But yeah, this is sort of, I had something similar to that where I guess I called it compute command. You can kind of see some of that here. I think there was a example too. Example. Compute.rs. Yeah. So you had like a node. Pretty basic. And there was a compute pass like stage or whatever that all the compute passes ran in. But it was pretty simple, like not very complicated at all. How did it run? I guess you just spawned the compute components here, but like that doesn't always make sense. But yeah, you have the pipeline handle. And then this dispatch component, which really is just the compute pass component, right? And then I had some things here for default, but yeah, work group size X, and then only once, so it would only run one time versus running multiple times. But yeah, the way I verified this, because I didn't have anything to actually bring the data back to the GPU, is or to the CPU side of things. The way I verified is with render doc and looking at the raw data to see if the buffer was updated correctly based off of this algorithm here, which is certainly not a great way of doing it. But yeah, those sort of my first pass, and it works very similarly to what I have now, but certainly not the best. Also, I swear that I don't know why this build failed, because this is not related to my code at all. And I reran the test, build and test on my local machine, and it passed fine. So I think this is a weird, like, I know this isn't Travis, but a weird, like, GitHub checks issue. Or it could be that Ubuntu is just broken here. But this did run before and between commits, right? Like this commit worked fine. These two failed. Well, this one really, why did this one fail actually? Curious if it failed in the same spot. Yeah, which is weird because I haven't touched that code at all. And not much changed between the two. But yeah, that's sort of my goal for Bevy Compute. I want to get this to a place where it can get merged in. And then from there, I'll work on maybe trying to provide some of the other implementations that I have, the ideas I have to have like a higher level exposure of compute for people to use. And I think another thing that's cool is the ability to let other people in the community come up with their own ideas and sort of, I want to play around with it. I don't think that there's one solution is going to fit everything, which is kind of why I thought of two different solutions. But I think we're going to need like a lot of different stuff for this. And I could even see the use case where blocking is something that somebody wants, right? Like maybe they're using Bevy in a non-game related way where rendering every frame isn't as important as calculating the data that they need to. Maybe they're like a data scientist more than like an actual game developer, but they're using this in a data sciencey way where they want to block in the system and wait for that data to be available. And I definitely could see that being useful. So yeah, I'm kind of excited and looking forward to trying to see what I can come up with in the future for this. I want this to merge first though before I start anything else. Because like I said, I think this is like the cornerstone, like the base of compute that really lets us sort of expand upon and come up with other things. So, but yeah, so I guess the rest of the time I have here, it's about another 30 minutes. I wanted to just knock through sort of the system param stuff in Bevy ECS tile map. And in order to do that, I think I gotta commit some of this stuff and figure out what I changed because I don't remember. Looks like a cargo format change that needs to happen. All right, for each tile entity. Somebody asked for that on the chunk. That's good to have, I think. Well, that doesn't exist in, right. Because it would be slow if I did that. But we're gonna rewrite a lot of this stuff anyways, so. Is that the only change? Yeah, let me just revert the file. And then these are just changes to texturing that I thought might fix some stuff with ISO, but didn't. But I think I want to keep those. Let's see. Fix ISO UVs. Yeah, I guess so. Let's just add these two things to this. Stage changes. Commit. So these. Okay. Just checking to see if I had a branch first. All right. Sweet. Close all. So first thing I want to do is rename this to layer. Okay. Layer bundle. No. Use the rename. Layer settings. Laser settings. Let's save all. Close to the right. There. Goes to the right. There we go. Map tile layer that can stay layer. Yeah, most of this stuff is likely going to get private or massively changed. Like this entire system here is about to get removed. When we implement our system parameter, which is going to be called map query. See map query. File query. We're gonna have to do this in a different way because that's not exactly what we need. We need like a query set because we're gonna have to access both mutable and not mutable tiles. Oops. What's that? I never pushed the code from this for yesterday. My bad. I will do that, promise. But in map here, system parameter. I need something like this, but this is going to be the layer query set. And we want to query layers here. Probably want the entity for the tile as well. We're doing this query, but query set. This has to be static. Call this the tile query set too. Oh yeah, we're even using the wrong. We gotta fix that. Query set. Maybe I'll just wait to push the code till next time. I don't know. It's in a usable place, but I don't need pub there. Use Bevy prelude. Use Bevy ACS tile. Yeah. Mod. Query. I guess. Wait, prelude there. Struct is never constructed. Oh, it will be. All right. Oh, and we need the system param dependency drive. Remember, it has to get imported separately. Okay, cool. So let's start with add tile. So I think that's going to be the first one we do. Oh, we'll need commands here too. Wait, how do we do it? Just like this? Or does it have to have the A? Yeah, it has to have the A. Okay, reference layers, add tile. But with add tile, we could do so much more now with this. It's gonna be really cool. Air. So we need an else here. So this is the case where the tile already exists. And then if this doesn't return, then yeah, we're gonna fail. So if the tile already exists, like we have to do something definitely different here. Oh, actually, we also have to get the layer that the tile's on. So let's add layer ID. And then we can query for the layer. What would be a good way of doing that? I guess just a find. Probably the mutable layer too, because I'm just gonna need it to grab it once. Okay. Layer. Layer entity. Mute. Layer query set. Self.layer query set. Then we want the first query mutable. Guess iterable mute, find. Or the layer dot. I guess we don't need these braces. Layer dot settings dot layer ID equals layer ID. Alright, let me just collapse this. We'll let cargo format it correctly. Alright, so the layer exists, then we do this stuff. Otherwise, don't do that stuff. Why doesn't it not like this? Oh, because it's possible that it doesn't exist. And we're not getting it by the entity, we're getting it with the find, so that's a sum. Yes. Don't need an if there. Just need to replace self with layer. And then we need another query set for chunks. So we have tiles, chunks, and layers. Yeah. And so I'm thinking we don't even get the chunk like this. Although, well, it still makes sense to get the chunk like this because we want to get the chunk entity. Layer.get chunk is private. Let's see, get chunk. Oh, it is private. Okay. We need to pull Morton index in. And then layer.tiles is private as well, but we can just expose that to the create level. Oh, actually, no. We're not going to do that because we don't even need a lot of this. This is going to be chunk now. We have to convert the tile position to the tile chunk position, if that makes sense. I think I have some code in chunk to do that, right? To chunk position, yeah. So that takes a global tile position and turns it into a chunk position. So we have the chunk entity here, but we need to grab the, this is gonna be okay this time. Chunk itself. Self.chunk reset. And we want this to be mutable as well. And I think it's the first one, yeah. We'll just do a get because we have the entity. So that's going to be faster than a find. And all these other cases where things don't match, we just drop down to this out of bounds, right? So the only time we actually return is when we're for sure about something. Right, this can be get mute. And then we have some more stuff we got to do here. Let's see. Entity. Chunk. Okay, and we're also gonna pull some of this out of here as well at some point, right? Like this sort of get layer code here. Just pull that out into like a get layer function, and then just call that. So we'll definitely dry this up later on, but this is kind of how we're doing it right now. But now we actually have like the data, right? The direct data for all this stuff, the layer. And in fact, I don't even think we need to mutate the layer anymore directly. The chunk entity we will directly mutate to add the new tile entity into it. Like we can completely get rid of the tiles on the layer and just look it up directly in the chunk. Like we haven't even used commands yet, right? Like the only place we're gonna use commands is probably in add tile to spawn a new tile, I think. Oh, we'll probably use it for the I also plan on writing like some like quicker updating code too. Like if you want to like update like a large set of tiles. But anyways, let's see what next. Like you pass an array like set tile, and then you pass in like an array of tiles. It's like set tiles or something. But yeah, maybe we should just call this set tile too, because it either creates or set the tile. So it kind of does both. And then this needs to be chunk local file position chunk dot to chunk position. And this gives us the tile entity. And if the tile entity exists, then we're probably good to go. Do we want to create the tile if it doesn't exist? Probably. So let's rework this a little bit then. I think if we do it like this, let Tile entity tile mute equal if let sum, and then we want to just drop down into none here. Because this is a block I can return, right? And it returns from that block. I just want to be explicit about it. I know you don't have to write return, but for my own sanity, I like to use it. Sorry. And then we don't care about the entity because we already have it, but we do care about the tile data. Query set that self dot query set that. Oh, I can't type today. That. And then we want the mutable tile, which is the first query. Get tile entity. Right, we already have the tile entity there, or the chunk entity there. I need to wrap this in another parentheses. Right, okay, so I can't use return here. Maybe we pull this part out into a separate get tile mute or something like that. If see here we can't do like an okay, right? We need like tile data. Well, I guess I don't need to unwrap that. Okay, so it doesn't know what this is yet because we have to return it here. Pretty sure I can't return this because it's not gonna, yeah. I thought there was a way of doing this with scope. I think it's always the last item though. So what we really kind of have to do here is something like let tile data equal, make that mutable, and then this returns tile data. There we go. I guess this mute isn't required. This chunk mute is though. Wait, is it? Yes, because if we hit the else here, then we're gonna have to add the tile to the chunk cache. That's easy enough to do though. Do we need the layer entity at all? Yes, I think so. Or wait, so we have tile data here. Now we just, what do we do with that? Do we even care about the entity here? Oh, I don't think we do. Maybe we can just return the tile data. Maybe we want it in the future, though. So we'll just leave it for right now. And then we want to spread the tile. in here like this. But we kind of right. There we go. Found struct. Oh, we have to do it like this, right? Yeah. But we want to keep the entity, the chunk entity there. Put a comma. What else does that? Yeah, that's it. Okay, and then we want to create the tile entity here if we don't have it. A tile. Am I missing anything for that, like, update tile stuff? I don't think so. So that's essentially what it does right here. I think. Yeah. Yeah, okay. Okay, in this particular case, we have to create a new one. So I need self.commands dot spawn, and then we'll immediately grab the ID, which is what we do here, kind of. Oh, we do need the tile entity here because we're gonna have to set the visibility flag, right? So we can do if visible commands tile entity. This is a bit weird. We might want to just have visible on the tile itself instead of a tag. But this is fine. Entity insert visible tile. Tile here. Else remove. Okay, and this would be the chunk entity. This has to be mutable. Okay, then we have the tile entity in here. And then we have to get the chunk tiles, and we have to get that local position. We still have that in here, chunk local position. Yeah. Equals entity some tile entity. Okay, cool. Um, okay, and then in both of these cases, we should have something to return here. Return, okay. I think it's better just to return explicitly for both. Otherwise, I have to do something to pass the tile entity up scope. So this is fine. And we didn't end up using the layer entity. Did we mutate the layer here? No, because there's no need to mutate the layer here. So we could probably drop the mute query. Just do query one. Iterate. Uh, hey, Forb. I'm working on the new interface for Bevy ECS tile map, which uses a map, like a system param with a bunch of queries built into it. So you can kind of see here. So here's what add tile looks like currently with this new map query. And it works instantaneously except for like when you spawn new tiles, right? There's not much I can do about like spawn like hard sinks right now in Bevy. That's something end users will have to work around as well with their own spawning, so it seems unreasonable for me to try to implement something like that. Yeah. Also, we renamed map to layer because that's really what it is. And it no longer will know about tiles eventually. And by doing it this way, we can automatically update the chunk cache. So yeah, that makes it really good just by that itself. Oh, and speaking of which, we need to change chunk slightly to have create. Let's not make it create. Needs remesh. Bills internal. Oops. Say by default it needs to get remeshed. Um, okay, cool. Yeah. So this is like, we'll have like even like a create layer 2 here, which will help you spawn like new layers. But yeah, this is pretty simple so far. And I think I like it much better than what we had before. Excuse me, than what we had before. Question is, can we use it right away? Kind of. Oh, see, this is where it gets weird, right? Like, if we spawn these layers, we're not going to have them available. So we're going to have to do something like strange there. I don't even know what. Like, layers still going to have some like add tile stuff on it or something. Or maybe we just don't support this and we like encourage people to use, what was it, the build iterate, which gives you a tile position. I don't know. The fact that Bevy doesn't give you like the data back in a query when you create it in that system is a little strange. It makes all this kind of harder for end users to kind of think about using. But still, I think this is the right direction for setting tiles. It also means if we have like a get tile and get tile mute, like all this is pretty much the same. So like what I mean is set, if you call set tile and you call get tile, you're gonna get the data back that you expect, except in times when it creates a new tile. That is a bummer. There is an open issue about this though. Let's see. It's called instant commands. Yeah. This different API seems interesting. Anyways, this does help alleviate some of the things, like, right? Like we don't have to worry about having a map, like a cache updater for the map, like each layer or maps or whatever. That's no longer required. And before we had a specific system for that. Where is it at here? Here. We don't have to do this anymore. And we don't have to do this anymore. Oh, sorry, we still have to do this one because people can remove tiles within their own. We don't have to, that won't be required anymore. Yeah, this remove tile is really important though right now. We can also query for tiles that have been removed. I think there is a like despawned or something. Added and changed. I think there's a removed. Could be wrong though. But yeah, we can get rid of this too. I can get rid of that. So less systems means this should work faster. Because we don't have like so many system dependencies. Like right now they're all depending on each other. So there's like it runs an order, but yeah, that's about it. Or let's do it add layer first, and then we'll go from there. Layer ID 32 layer. I think we can just return an entity straight up from this because there won't be any chances for failure here, like there is with the set tile. We're always adding something new. We're gonna look at this example. So yeah, this is basically the part. Maybe we should just accept a layer bundle and make this easier, right? Mostly like just a convenience thing. Oh, that makes it a bit more complicated though, because I can't actually call build. But we can rework build so that it gets the right layer ID anyways. Entity ID. Wait, how do we do that? If people are calling build before they add the layer. We could just have them pass in the layer entity too. But then at that point, what is this really doing? Like, is there a point? Because all this would be doing just this part here. We can at least ensure that the layer, let's go to the layer bundle, rename this to layer. I pull it out like this. I think so. Then we can just basically guarantee the layer ID here. Okay. That would mean like when you create a new, like you would, like right now we do like layer settings and then I think one of those is the layer ID. We could just drop that and just keep that internal. That might be a good idea. But yeah, for example, like the layers example, like we specifically set it like this, but we wouldn't have to do that anymore. And same with this. Wait, why do we do this? Oh, that's the texture index. Never mind, that makes sense. The transform though, we do want to set that here. In the map query. This would be layer ID. Not exactly how I want to do it, because I want to preserve the transform in its entirety. So we should pull that out too. And then do transform.translation equals .z equals there. Yeah, and then we don't need the +1 here. Just like that. There, so just some convenient stuff to make layers a little bit easier. Translation gets automatically set. You still have to create your own entity and your own bundle, but that lets you do things like setting the transform for the bundle or adding like parents, children, that sort of thing, because you control over the layer entity a bit more. I mean, you still get the tile entity here, right, on the return, but what I mean is the layer itself, you can pass in the layer entity, which we need for chunks. But maybe we think about creating the actual chunks here instead. I don't know. To think about that a bit more. So set lit tile makes sense. Kind of other APIs are we gonna need? I don't think we need anything else. We need to notify to update, but like we should be able to just use map query in this example here fairly straightforwardly. But like add tile here is not gonna work right. How do we make that work right? Because we're building the chunk entities out. It's really inconvenient to not be able to do add tile like this. Maybe we just provide a convenience function for it. I don't know though. Well, I think I need to think about that for a little bit longer because somehow I need like a hard sync between this and this. Or allow people to still do it and hide the fact that it's not using a query or something. I don't know. I think we had discussed actually passing in a layer. to here. But that's not going to solve our problem of still needing access to the chunks so that we can update the cache directly. What if we have a layer builder? And it kind of works like our commands does in Bevy ECS. So, and then so you like create a layer builder, you pass it layer settings. And it has like all the information about chunks and tiles. Like you just say, add a tile here, here's the tile. And then when you actually build the layer, like layer builder dot build or whatever, it would then go and create all those tiles. Oh, that would be really useful. Let's see if we can add an API like that. There wouldn't be much, right? Like it'd just be like a list of tiles pretty much and the settings for the layer. So do I want it to be a vec or a hash map? I think a hash map because we'll want to know. Well, do we even need to look it up? We could just do uvec2. We don't care about the order of the tiles. That doesn't really matter. We just need to iterate over them fast. Okay, like that. Let's bring Bevy in. Okay, layer builder. Oh, you know what? It might be worthwhile to have a hash map here, or at least a Martin encoding, because yeah, let's do with Martin encoding. Just for right now, I mean, I do plan on removing Martin encoding in the future, but for right now, it's fine. So this is what I want. Inside of the layer builder, it gives us a map size, which we can use for the capacity. I guess this should be a sum, or not sum, option. You know what I mean? Result tile. Well, what's the result? Just nothing? There. Okay. and then we error. We drop immediately. If there's any error, like, yeah, not immediately, but let's get the Morton index. Okay, and then if Morton tile index greater than, I will say less than, okay, then we can store the tile if that's the case. Why is this all weird? Oh. There we go. Tiled up. Morton tile index equals some tile position tile. Just call it set tile because we'll just overwrite the existing tile if it doesn't exist. Okay, and then it probably is handy to have existing tile support as well. Get tile. Did I close the builder? Oh wow. Return. Okay. Why isn't it like this? And option. Alright, because the we only want to return if that tile exists. And then unwrap it. Oh, guess we don't need to do it that way. Let's do it this way. If some tile equals there we go. All right. Tile mute. Top position and mute tile. Mute tile and mute. And mute self. Okay. And then we need like a build function. creates a map bundle. Creates a layer bundle from the layer builder. Useful for creating and modifying a layer. Layer in the same system. It's the layer builder using the layer settings. Set a tile data at the given position and it's a reference to the tile data using using a tile position. A mutable reference. Okay, and then this is just going to be animate itself. Layer bundle. Make that mutable. Wait, why is tile not clone or copy? I mean, shouldn't it be copy? Yeah. So why is this complaining? Oh, because it's an option. Tile might exist. Do I have to return a tile here? Yeah. It would be good if the output was an option though. I think we're gonna change that to be option tile. Tile.chunk. Tile chunk. If tile let some tile equals f tile position mute. Yeah, like that. Alright, but this is still gonna complain because we have like a UVec in there. I guess we're gonna have to pull, we're still gonna have to do something like if let some equals. I still want a way of building like a sparse map with this. So build tiles shouldn't expect there's a tile for like you have a complete set of tiles. That doesn't make any sense. So we should be able to have sparse tile maps here or sparse layers, right? I guess have to return. If we did else there, we wouldn't. I don't think we would have to return here, but it's fine. Okay, so we have our layer. We built it. Look at our sparse tiles example again. Once we build the layer, that's it, right? Like we're good. Yeah, we can just return the layer bundle, which is really just gonna be this, I think. Yeah. Cool. Okay, so now we should be able to use the layer builder here instead. Like if we redo this code to use the layer builder, it's gonna look much better. So why don't we do that, right? Layer settings equals layer settings. Let's go say you don't need a layer ID to specify here. We'll still let you see it though. That's probably useful. This would be a layer entity. Let layer builder equals layer builder new. I gotta export it from here. And then we'll give it the layer settings. And now we'll just call layer builder add tile. We don't need commands. Oh, you know what? I don't think we made public. Oh, they're all public. Oh, because it's set tile, right? Visibility stuff. Oh, we'll have to add that, but for right now, ignore errors. Yes. The 0 there. This should be layer entity. And we should be able to just do, well, actually, we want to use the new query stuff. Should we also have the export? Okay. And then we need map query. Mute map query. Create layer. Layer entity. Layer ID. Oh, which in our case is 0. Layer bundle, which is the layer builder dot build. Oh, and maybe we just pass. Maybe we just pass the material handle to create layer and the layer builder directly. And then this stuff could all be internal. Yeah, I like that instead. So let's do it like this. Layer builder. Create layer. No, we want the layer builder here. We just need the material here. And meshes, we will just bring in from self. It says res mute. A asset mesh. I think that's right. Not quite. Assets. And mute self. Self commands. So we material handle. Does this need to be mutable? No. It returns something new. Doesn't mutate anything. Cool. Okay. That's pretty straightforward. So now in this example, we just call create layer and get rid of meshes. We don't have to bring that in anymore. We still create our material. Okay, and if I run this, let's see, I just got to write it out. If you're still there for, what do you think about this? How this is looking here so far? Well, it didn't work, but we will fix that. 26. With capacity should be right, unless we're going outside of the range. 0 to 16 should be right. Oh, you know what? Actually, that does go out because it's sort of this new sort of builder. So I added this layer builder struct that helps you build layers, and then let you edit them in the same thread. Like it doesn't have anything in the same system. Sorry. So it doesn't have anything about chunks or anything like that. It's just a flat array vec of tiles, and then it has like set tile, get tile, get tile, mute, and then it builds a bundle, and you can pass it to the map query to create a new layer. I should probably make this consume. Oh, it does. It takes layer builder directly, so it will consume layer builder. I like that. Okay, cool. Yeah, I mean, what it lets you do is like it sort of defers the building of like the chunks and stuff until you finished sort of setting everything up, right? So this lets you call set tile. You can even do like, we'll have neighbor lookup stuff in here too, I guess. Any additional functionality, like I'll let you sort of like generate your map if you need to, like procedurally or however. And then at the end, you create the actual layer bundle entity and pop that out. But I do have to figure out why. It says the range here was 16. Length is 0, but the index is 1. Oh, you know what? We have to fill this. We can't just say with capacity. This has to be like this. We do it. Maybe 16 was right. No. 16 would definitely throw an error here. Index is out of bounds. Length is 4, but the index is 4. What? Why is that doesn't make sense why it's 4. Are we rounding up? Yeah, we're sealing here. Let's see what the map size is. Map size is 4. What? How is that possible? Oh, you know what? No, I know why. Let me go back to layer code. We need to calculate the tile count. So we need the rest of this stuff here. There we go. Map size, we don't even care about map size. So we don't even need that. Okay. There, that should work now. Okay, I think that works, but nothing rendered. Means we're doing something wrong. Let's debug the tiles here, I guess, and see what we get. Is this trace too? No, just info. Wow. Okay. Oh, we do a double tile. Oh, goodness, that's not good. Okay, so we do have some tiles. They're all just zeros, which is what we expect. Um, okay, so I think maybe it's not remeshing. No, it should remesh. Because it'll do it when you add a chunk. Um, Where's tiles? Let's go back to here. So we set the tiles. We know that create layer works. Does it though? Creates our layer entity with the layer bundle. That should work. It should give us all the chunks and stuff with the build command here. I guess let's run with trace and then maybe we can see if it remeshes. No, well, let's try it at least. Okay, it doesn't actually remesh, so something's not working as expected. We do insert the bundle. Build should create the chunks. Text position. Oh, wait. No, we should set, yeah, no. Because build tiles should set the tile in the cache. Right here it does that, so that's still right. Probably delete that line, but I'm not gonna do that yet. Let's just take a look with render doc real quick, I guess. Do we have any draw calls? We don't. Okay. Yeah, perhaps it's not actually creating the chunks or something. Let me follow the code here. I mean, this should definitely create chunks that have build tile. Chunk entity size match type. Wait, what's tile map data? Oh, right. Okay, never mind. I know what that is. I just want to see our chunks. It must be because we're getting to our yeah 0, 0. Wait, why is there only one layer? Oh no, there's 0, 1, 1, 0. Okay, and there should be one more 1, 1. Yeah, okay, so that is right. Look at layer again. Chunk entity, chunk transfer. With children, that should be all right. And then in the chunk itself, build tiles. It's definitely calling this stuff. Wait, is it? Like debug. Okay. This is adding the new tiles. It's like we're not, maybe visible is returning all. So it doesn't even know that chunk was added. What? Does commands not work in a sys program? Or is it because we have this weird situation where we have like a double commands? Like we have commands here and then commands inside of map query. How does the system program handle two different commands like that? I think that's the issue. I was hoping that would not be an issue. What to do about that? We could just pass in commands to all the things that need it. That's a mess though. Let me ask it on the Discord. You see this? System link. System RAM. This is invalid, right? Well, let's try that, I guess. While we're waiting for that answer to be given. So this will already be and mute. Commands. I was kind of hoping we didn't have to do that, but it's okay. It's not the worst thing. Okay. And then here we just pass and mute commands. It does seem like something that would be common, but I don't think Bevy can differentiate. Like, it's not smart enough to differentiate that you have like two commands or something. Yeah, see? I think we could definitely add that as something that's like doable, but Bevy would need to know that there's more than one command buffer, right? Because this is like it's essentially like a queue. So like when we have one inside of map query, you have like two different queues, and Bevy just ignores one of them, it looks like, and only uses one. So it would need to know you have more than one queue of commands, and then how would it know like what order to also run those in? Because they're two separate queues, right? So if you queue something, well, we were talking about we used to have commands in here like this, and then in here we have commands as well, but also the map query. So if you're running code through here, right, that's not going to work because you have like the order is not going to be right. Now, What would be better is if it was the same command here as it was here, and then you guaranteed, I don't know how you would guarantee mutability though. Like, right? Like you couldn't mutate it. I guess because you're not mutating this the same time you're mutating that, you'd have to guarantee that your system param isn't getting mutated the same time as the commands, if that makes sense. But yeah, with ECS v2, I think each command you have will have its own command queue and they'll be flushed in the order of declaration. Yeah. Yeah, it is weird. But it's, I mean, it's fine for right now. I'm just gonna do what I'm doing here, where you just pass in commands. I prefer not to do that, but there's no reason why I can't. So, and that fixes the issue. It makes it a little less convenient for users because they'll have to pass commands into these map into map query, each map query function, which is a bit weird. Another way I could do this is I could have like a set command and like wrap commands in some sort of like arc mutex thing. That would be really weird though. I don't even think you'd need to do that. Cause it like technically the my spelling param right here. Let me just do Anyways, this works, which is cool. Not ideal. I don't think it's okay. It could be better. But yeah. Now to just add more functionality, right? Map query needs to have a lot more stuff. It needs to have like get tile stuff, set tiles. So you can pass in a vec tiles and it'll set all those. Honestly, we could probably, like, there's no reason why the layer, we have to pass the layer entity in here. We could probably just return the layer entity from this. I wanna do that. Yeah, I think that's a better API. And then we can just ignore it if we don't want to use it. Uh, so it's not. We could use a secondary command buffer if those existed in Bevy, but they currently don't. So like we only get one commands per system. So we have to pass it in to the system parameter. Um, Ordering is kind of important because if, like, for example, you wanted to do something with the layer entity afterwards, and you did like commands dot layer or dot entity layer entity, you would expect this to exist, right? If you didn't, if you did something like this. So like this way, the ordering is right. It might be valid looking, but I don't think it actually works. Use secondary command buffers exist? Question mark? Was under the impression that they do not yet. like if secondary command buffers exist, you would think like you'd have like a create command, like, right? And then this is like your secondary buffer. And then that inserts like basically an ID in the buffer, right? So that when you get to the end, I don't know how you would do mutability and like access and all that. You'd have to figure that out, but that would technically kind of work. That did not work. Not sure why. It might have been that it didn't work because we were creating the actual entity here. Like, I don't know. I don't really want to test it out because I want users to have our own commands inside of that system anyways. Yes, let me just try it real quick. Just real quick. Let's see if this works. Anyways, so it definitely doesn't work as expected, which is okay. Like, I want it to be like this anyways because we want the order to be right so that people can add like their own components to the layers if they want, or to change those. Like this doesn't really give you an option to change how the entity is spawned. So maybe it's bad that we pulled the layer entity into that. I think I'm gonna pull it back out. Because now we can do something like see here. Form default insert global transfault. All right, so we something like this. And then if we change the position here, we change the whole map position. Didn't mean to pull that in. Commands. Oh, right. This is a bit weird here because we're gonna see something like this. Um, I actually don't even care about that. But yeah, so now we can offset it. Like if we do, we want it to show up in the center of the screen, we can do 16 times 16, which is 256. So like minus 256. Minus 256. And that will make it show up not in the center, but close. Center would be 128 by 120. We'll run that next just to verify. Yeah. So this should be the center in pixel. Okay, cool. So yeah, by keeping the layer entity outside of create layer, it lets you have a map like this. But yeah, it is really weird that we can't like I wish we could pass, like, this was commands, right? So then it would have the same type, so we could pass it in the same way. We could have like a create layer child or something, and then you pass in a child builder instead. But then we kind of have to have a build child and then inside here we have to have a chunk dot build iterate. Like it just keeps going on and on. Like build tiles child. Uh, yeah, that would be messy. But you could spawn like all your layers. You could have like ground layer and so forth, and then just sort of create them like that. It's a bit weird. We could just ask for the map entity here though, and then do this part, this with children part internally to create layer. I don't know if we always want people to like have like a map entity though. Technically, just a single layer can be its own map entity. There's no reason to have more than one. All right. Well, I think that's like we've gotten to like a good place where we have like a testable example. Let's see. Um, yeah, and I think that's it for today, guys. I gotta go do some stuff. So, I hope you enjoyed. And I think I'll be back on Monday or Tuesday, one of those days. I think Monday I will be back and we'll be working more on the game side of things. So, I didn't have a lot of time today, but I did want to just quickly go through this real quick and sort of test this out more and start building sort of the query out, and then came up with this layer builder idea. So that definitely feels like a lot better of an interface for building out layers, and then we'll have fun. Like set tile definitely feels a lot better for setting tiles with using this map query. So we're just gonna keep expanding on this. I probably will do a lot of the work off camera though, and then you'll see a big commit in the future, and maybe even a 0.4 release. I think it's 4. Yeah, 0.4. So, but yeah, thanks for watching, guys. Hope you enjoyed. And like I said, either Monday or Tuesday. I think it's Monday. I don't know. It kind of depends on schedules that I don't set, so I forget them. And then, but yeah, I will definitely, if you want to get notified, hit that follow button. But yeah, more game stuff. We're probably gonna work on just more attribute things and more of like, okay, if this weapon hits, how do we calculate damage, right? We need like a system to do that, or like a function that takes like a weapon and then it takes a list of attributes for the target that it's trying to hit. Attributes and stats for the target it's trying to hit. So yeah, we'll do that either, like I said, Monday or Tuesday. But yeah, thanks for watching, guys. Have a good day.